Alright, so I've been given a truck to diagnose today, and the check engine light is on, and when I flip through the dash, surprise, surprise, 4364 FMI 18. So I'm going to do my best to show you how I troubleshoot this fault and what my conclusion is on what the repair should be. When I hooked up to Cummins Insight, one of the first things that popped up was this screen here. And what this is telling me is that the ECM needs a new calibration. This is the new calibration that needs to be updated in the ECM. So write down that number if you can. This is the calibration that is in the ECM right now. So you see the only difference is these last two numbers. This says 3.7 on the old, and the new one's 3.9. So that means it's going to be updated two software updates. If the save button and the calibration history button are enabled, you'll want to press save, and what that's doing is saving the new calibration to the to Cummins Insight in order for you to put that into the ECM. Also, calibration history, if that's enabled and you click on that, you'll be able to see what the updates do from, like, say 38 and 39, and they'll tell you which fault codes that they change or help with. So it'll say reduces the occurrence of fault code 3774 or whatever, reduces the occurrence of fault code 4364. So in our case, we're working on fault code 4364. So if we saw in the calibration history that for this update it reduces the occurrence of fault code 4364, we would think that ECM update might help with the occurrence of this code, and doing that update might solve your problems. But I'll show you how to look up the calibration history apart from Cummins Insight when you don't have that enabled. So I just exit out of here, hit OK. I'm going to open up my fault codes. There you have it. Your active code is 3582. This is the different number than 4364, what it said in the dash, but it's the same fault code. 3582 and 4364 are the same. SCR catalyst conversion efficiency. Data valid but below normal operating range. See, and you'll see 4364 over here. And so what that's telling us is that our after treatment system is not converting NOx the way it ought to be. So either the SCR is failing, or you got a problem with sensors, or DEF, something along those lines. So we're going to troubleshoot that next. So what you do is double click on this fault, and it'll open up this fault screen, and it's asking, is this a heavy duty engine or is this a mid-range engine? This one is a mid-range, and the page cannot be displayed. So I'm going to show you what to do with that. So basically, well, I know for sure for Detroit, Cummins, and International, there's websites where you can go to get manuals and a lot of really helpful information, and knowing how to do this has probably helped me the most in diagnosing after treatment systems. So, but in order to get your calibration history for the ECM update, and as you saw when we tried to open up the fault code, it would not show us the troubleshooting steps. You can also access that fault code troubleshooting steps through this website, CumminsQuickServe.com. but you have to have a username and password in order to log in. So if you don't have one, I don't know if this will be helpful to you, but if you do, figure out what it is, and I'll show you what you do once you get in there. Once you're in Cummins Quick Serve, it's going to have a little box here on the left that is asking you for your engine serial number, and you're going to want to put that in there because that's going to update Cummins Quick Serve's information on everything with your truck that you're working on's information. And the way that you get the engine serial number is through Cummins Insight. Click back on Cummins Insight, and up here at the top of the screen you can see engine serial number is right here. So you go back to Cummins Quick Serve and enter that number in. ECM has been updated. So now that our engine serial number has been updated and it has our truck's information in here, in order to see the calibration history, to see what this calibration is going to update and fix, go to this tab on the bottom left, My Applications, and expand that. And then right here it says ECM Calibration Revisions, and click on that. It's going to bring you to a new page. So now we have our ECM Code Search. So what you're going to want to do is put in those first numbers of your ECM code. So back here at Cummins Insight, your ECM code is BZ90007, and that's what we're going to put in Quick Serve. BZ90007. Search. So now it's updated. You see there's only 2 there, but if you scroll down, it's going to show all the revisions. And so we were at 37 on the small number, and so we want to find 38 and 39. Go to the next page, and 39 is the most updated one. So we go over here to the left, and we see 37 says reduces the occurrence of fault code 3697, and has quite a few, but 38 and 39 don't show us that they're going to really update anything of significance to us for this fault code. And remember to scroll up and down on here, because this will show you more information that might not be shown when you're looking at it. Alright, I just got confused for a second, because when I tried to go back to the service tab from where we were looking up the ECM updates, it didn't have any of this information. And it was because when I clicked on applications down there and it opened up a new screen, the new screen didn't have our engine serial number in there, so it wasn't giving me any of this information. So if you have run into that problem, re-enter your engine serial number. So here we are. You want to get to the service tab, and that's going to bring up all this information, which is a lot of good information. But in order to get our fault code troubleshooting steps, we want to go to here, Fault Code Search. This is a great little feature in this website, because here's what you can do. If your engine has multiple fault codes, like this one does, 3582, 0731, 0286, what you can do is put all those in here, And when you hit analyze, it's going to tell you which ones to troubleshoot first. So in this case, these two, for some reason, unless I put them in there wrong, no, are not reading right. And so basically you can just remove them. But if you had some fault codes that made sense, it would tell you which order to troubleshoot those fault codes in, which is great. So now you hit analyze. Okay, this is our primary fault code that we want to troubleshoot first. And if you had other ones, it would give you the order 1, 2, 3, 4, whatever, in which to troubleshoot. And so click on 3582. And now this is going to open up your troubleshooting steps, and we're back to that screen. Is this a mid-range or heavy duty? Mid-range. And now finally we have our troubleshooting steps for what we're going to do. This tells you what reads this information, component description, the engine control module, monitors, yada yada yada, where the location of the component is, conditions for running the diagnostics, conditions for setting. So this gives you a lot of pretty good information, but here at the bottom is the actual troubleshooting steps. Click on that link. Now that we're here, it gives us a troubleshooting summary at the top. There's all the steps we're going to want to go through. I'm going to check for all these active and inactive codes, which is the first couple of steps. We're going to check for the correct after treatment inlet knock sensor and outlet knock sensor. Make sure that actually the sensors are the correct ones. We're going to check the DAF dosing system, quantity and quality. Is there any leaks between the tank and the injector? Check the quality of the DEF. Is it contaminated? Is it good? Check the filter. Check the dosing unit, the DEF doser. Check for DEF deposits in the decomposition tube. Check the DOC for face plugging. Check the engine control module for calibration and clear fault codes. We checked for the calibration, but we saw that it's not really associated with this fault. Check if an ECM calibration update is available. Yep. Perform a stationary regeneration and check for active fault codes. Check the SCR part number. Verify the SCR part number. Clear the fault codes. Disable the fault codes. Alright, and then it's going to give you more information on each step as you go. Alright, so I'm going to try to take you step by step through each one of these troubleshooting steps. And the first ones are really quick and easy checks. And it's basically wanting you to check what codes are active or inactive. So the first step is 3582 active? Real easy. Go to Cummins Insight. Yes, 3582 is active. Next step. Are any of these other codes active or inactive? So you could read the codes there. We know they're not. We have 2 inactive codes for something unrelated. Next step. Same thing. Check for these other inactive or active codes. We know that they're not. And then what they're asking for is basically, are sensor codes active or inactive? Are DEF dosing codes active or inactive? And it's asking that because those things can cause NOx conversion efficiency problems. And then again, are these codes active or inactive? No. And so we move on. Check the after treatment NOx sensors for the correct sensors. So what I want you to do is to check the inlet and outlet NOx sensors to ensure that they are the correct sensors that have been installed. I checked the history on this truck, and the outlet NOx sensor was replaced over a year ago. and has not had any problems. And the inlet knock sensor has been on there since the beginning, and this truck has over 140,000 miles on it. So I'm assuming that they are the correct knock sensors, because if they weren't, they would have been causing problems a long time ago. But I'm going to show you the location of each one of these knock sensors on this truck, just so you know. So I'm on the passenger side of the engine compartment right now with the air filter and the coolant reservoir and the radiator and fan and the engine. And so on the hot side of the engine, the passenger side of the engine, down deep, there's your turbo, and behind your turbo there's a little heat shield, and there's your inlet knock sensor right off the back of your turbo, where your exhaust begins its journey to leave the truck. So that's picking up the knocks coming out of your engine. And so this is always going to be your higher knocks reading, because there's nothing really lowering knocks at this point. This is what's coming straight out of your engine, and what the outlet knock sensor wants to read is something much lower than this, so that we know the after treatment system is doing its job. You see it has a long cord, and I don't know if I'll be able to get you there, but I don't know if you could see it, but back there where that black plug is, you could see the harness on the top of it. That's where your inlet knock sensor module is mounted. And there's a harness right there at the bottom, that little red clip that connects to the white. That little square box is your inlet knock sensor module, where the harness connects to it that goes to your ECM. And so you have to remove a couple things to get back in there in order to get to the rest of that sensor module. But that's where it's at. You'll have to remove this airbox housing and maybe a couple other things in order to get back in there, in order to replace that knock sensor if that's your problem. So now I'm looking for my outlet knock sensor. I'm underneath the truck. Here's the back of the transmission and the drive shaft, and right next to it is the exhaust pipe. Comes down, goes through your after treatment system, through the DPF, through the SCR. There's the doser, and here it comes out of this exhaust pipe, and you can see right here is your outlet knock sensor, and the wiring harness runs up and above over the frame, and then back down and mounts right here. And again, it's another module that has the plug which goes to your ECM, and then this plug is not removable, not serviceable. That goes to your outlet knock sensor. Remove the 2 bolts, unplug it in order to replace that one. But this one, like I said, was replaced before. So your outlet knock sensor is always after the SCR, and the exhaust pipe runs straight out the back of the truck. So it's picking up how much NOx you're putting out into the environment. Our next step is to inspect the DEF dosing system for external leaks. And this should be fairly easy, because when DEF leaks, it formulates white crystallization. That's pretty easy to spot. And here's the DEF tank. Here's the header, or the sending unit, which picks up your fluid level and stuff like that. And here's your supply line. And we're just going to examine and make sure that nothing is damaged or obvious white leaks. So here you can pop this, give it a sniff. Sometimes depending on the fluid level, it'll be strong in the odor of urea, or it won't be, but you don't want to smell diesel or anything else, and we'll be testing the quality of that in a different way. But you want to get under here on the back of your DEF tank, or your DEF lines, in your pump, in your DEF filter housing, and we don't see any crystallization or leakage or damage. And we want to just examine as they leave and go all the way over. That blue line is your DEF line, and it runs here and then comes down to your DEF injector. And so as we can see, we don't see any DEF coming from DEF line. Everything looks to be in place. You should check for crimping too, but usually that line is pretty protected from being crimped. And these two are your coolant lines. Runs coolant through this doser. And so our DEF system appears to be free of external leaks or damage. Alright, your next step is to check your DEF quality and quantity. So it says check for debris. It's really hard to see inside that DEF tank, so I don't know if you'll be able to do that, but use your refractometer in order to check the DEF quality level. So that's what I'm going to show you what to do right now. I use a long piece of hose and dip it down inside the DEF tank, and I take a small sample and I place it underneath this lens on that blue thing here. When I look into this refractometer, I should see the DEF level between 31 and 33, 35. Right there you can see that the blue line is right at 32.5. And that's big like that because that's where it's supposed to be. So our check with the DEF fractometer has proven to be good. Sorry, that's terrible. So now that we know that our DEF quality is good as far as the refractometer goes, I want you to check your filter to see if any kind of blockage has been picked up into your filter, and which would cause less or no DEF to get into the injector and into the SCR system. There's two ways that we're going to kind of check this already, so I'm going to skip this step. But if you want to pull your filter and examine it and change it, that's up to you. I showed you where it was on the back side of the DEF tank itself. But when we test the DEF quantity that's coming out of the doser, we should see if there's any kind of restriction and the DEF's not getting to our SCR system. And not only that, but I checked and saw that the filter on this truck had been replaced recently, so I'm going to skip this step. Next on the list is testing your actual doser itself. This is an important test. So what we're going to do is we're going to pull the DEF doser off of that decomposition tube. We're going to put it in a measuring jar or beacon or whatever you have to measure the amount of fluid that it's dosing out, and we're going to run that doser pump override test in Cummins Insight. So I'll show you how I do that and how much fluid you should be looking for. So here's my DEF doser again, and what I'm doing is just removing the 3 mounting bolts here, in order to remove it from the decomposition tube so that I can put it in my measuring container and run the DEF pump override test. What you have here is the DEF dosing into this, the electrical harness giving it power, telling it how much to dose, and then your 2 coolant lines on the back. So what I've done is I've put the nozzle of the DEF injector inside of my measuring beacon, and I didn't unplug anything else. Just set my beacon up on a couple blocks of wood because this has some pressure because of those lines going on it, and so if you're able to wedge your beacon up in there and hold it in place while you run the test, in order that you collect all the DEF that's being sprayed out of here, so you can measure how much it's putting out. That's the way I do it. So we're going to come back to Cummins Insight. We're going to get rid of that fault codes tab, and we're going to go to ECM Diagnostic Tests. Make sure the key and the ignition is on, but the engine is not running. And then you want to find your DEF or diesel exhaust. You want to find our diesel exhaust fluid pump override test. You double click where you hit start at the bottom or next. It's going to tell you to remove the nozzle from the pipe, which we've done. Hit OK, and when you're ready you're going to hit start. I already ran this test, but my video was messing up. But here's what's going to happen. Your pump is going to start priming. It's going to get up to around 132 psi. Then once it gets up to pressure, the test timer is going to start, and it's going to tell you that it's running 0.3 gallons per hour. So the test will run for 6 minutes, and you just leave it in that measuring cup for 6 minutes, and the pressure should stay between 129 to 132, give or take. As long as it's staying up and pumping DEF into your container, it's good. So let it run for 6 minutes. 0.3 gallons per hour should be between 87 milliliters to 108 milliliters. Every time I run the test, it's usually right around 100 milliliters. So here's the conclusion of the DEF doser test. We have 100 milliliters, right around 100 milliliters of DEF that it dosed. And as I was saying before, that this test runs for 6 minutes as spraying at 0.3 gallons per hour, which, if you could do the math, but every time I've run this test on the Cummins ISB and it's passed, it's been around 100 milliliters. So that's a good idea of where it should be. I think that the manual says it should be between 86 and 108 milliliters. So there you have it. Our system is dosing the proper amount of DEF. So the next steps in the troubleshooting guide are: check the decomposition tube for excessive DEF deposits. Now you can refer to the video I have on fault code 3749, which I take out the DEF injector and I use a borescope to inspect inside of that decomposition tube, and I have some pictures and stuff on there to show you. We already did that on this truck. So where your DEF injector connects to that pipe, that's your decomposition tube, and you want to make sure that there's not a bunch of DEF built up in there. But we know that this one's clear. So I'm going to move on to the next step in these troubleshooting steps, which is check for DOC face plugging. Now, I don't understand exactly how this would cause an SCR efficiency code, but I think there's other things that'll tell us if it's the DOC. And right now I don't see that this would be the problem. I'm going to skip this step. We know that there's an ECM update, but it's not pertaining to this fault code right now, so I'm going to skip this step as well. Now this is the step that I think is really important, and this is going to help us diagnose what's going on. We're going to run a regen, but before I do, I'm going to unplug the electrical harness to the DEF injector. And the reason I'm going to do that is because I don't want it to be spraying DEF in the system while I'm running the regen. And what I'm going to do is monitor my NOx sensors, inlet and outlet, and by the end of the regen, once they're up to temperature and everything's going the way it should be, I'm going to read those inlet and outlet NOx sensor readings. And if the inlet is out of whack or the outlet is out of whack and it's reading something it shouldn't be, and I'll tell you what that is, then we're going to know it's our sensors. If they're not, if they're within 50 parts per million of each other, as they should be since there's no DEF dosing, then we're going to determine that the problem is our SCR catalyst. So I'll show you what we're going to do next with the regen. Before we run the regen, we got to climb back underneath here to our doser and unplug the electrical harness. Alright, so just push down on your clip and pull up and kind of push it out of the way, away from the hot pipes, because this is going to get really hot here in a second. And you're going to have some new fault codes in the computer and in the dash. Don't worry about it, it should still run a regen, but we need this unplugged in order to get the correct reading on our sensors. So now I'm back in the truck. I've started the truck, so the truck engine is running. I'm making sure that my computer is still connected to the ECM. The next thing we're going to do is run a regen. This is very important. I have this whole document on a different video under successful or good regen parameters, but this is the ISB 6.7, the engine that I'm working on right now. What a good regen will read, and what I want to pay attention to is the inlet and outlet NOx, really mainly the inlet right now. So it says right there above it, NOx readings taken during last portion of the manual regen. So a regen usually takes somewhere around an hour. And so we want to monitor what these sensors are reading toward the last 10 minutes of the regen, when it's at its hottest and it's gone through all of the process. And so what's important is that inlet NOx sensor reading right there. So a normal inlet NOx sensor reading is going to be 200 to 250 parts per million. So with our DEF doser unplugged and no DEF being dosed into that system, our outlet NOx sensor should be reading close to 200 to 250 parts per million, because there should be no conversion of NOx since nothing in the system is converting it. The DEF and the SCR are used to convert it together. When you take away the DEF, there should be no real conversion except for maybe some old built-up DEF, which should have burned off by this time at the end of the regen. So this is what we want to pay attention to. So right now, I'm going to start the regen. So right here is after treatment diesel particulate filter regeneration. On some of the newer model Cummins, they have an after treatment SCR systems test, which is very helpful. It'll do all this stuff for you. So if you have that, run that, and I'll show you how to do that in another video. But if you don't have that, this is the way you got to do it. So I'm going to double click on the regen, brings me to this screen. I'm going to make sure I'm outside in a safe place, not around people, when the parking brake's set. I'm going to hit start. It's asking all those things. Are you in a safe place? Yada yada yada. Yes. There we go. You should hear your engine automatically rev up. The regeneration has begun. Now, in order to monitor our NOx sensors, we got to go up here to Data Monitor Logger. Click on that. Don't worry, it's not going to stop your regen. It's just going to bring you to a different screen. Now you can pick a certain thing. I usually just pick all parameters. Double click on all parameters. And then you can move this to hide it and get here. Now I want to find intake and outtake, or inlet and outlet NOx sensor readings. I'm going to scroll down. There we go, right there. After treatment intake NOx, 0 parts per million. And a couple, let me highlight it for you. 0 parts per million, corrected, reading stable, reading not available. See, when it gets to a certain temperature, this is gonna change. It says reading not available right now because it's not reading. They're not at the temperature where they're gonna start reading. Once they get to a certain temperature where they start to kick on, it's gonna say reading not stable. So that's not what you want. It'll eventually say reading stable or something along those lines. You'll know that you're getting a correct reading from your sensor. Same thing down here with your outlet. So these are the two things that we're going to monitor at the end of this regen to see where they're at. We want them close together at the end of this regen. If they're not close together at the end of this regen, we know there's a problem with sensors. If they are close together by the end of this regen, then we know that our NOx conversion problem, since our DEF is working, since our DEF quality is good, since there's nothing built up in the decomposition tube, we know that it's either a sensor or it's your SCR itself. And so that's what this is going to tell us right here. So we'll look at it towards the end of the regen. All right, so here we are, a little over 30 minutes into our regen, and you can see the inlet NOx is hanging out around 175 to 185, and the outlet NOx is following between 155 and 165. Now on that sheet it said that we wanted the inlet NOx to be between 200 and 250, but not to be super strict about that, as long as the readings are somewhat close. And I'm thinking that our inlet and outlet NOx are reading stable. They're reading pretty close together, within 20 parts per million. So if I was getting over 50 parts per million difference in those, I'd be concerned. But they look to be reading pretty stable and pretty close together. So I'm going to wait till this regen finishes, and I'm going to keep on monitoring this inlet and outlet NOx, see if anything changes towards the end of the regen. But as of right now, I'm leaning towards the SCR catalyst itself, which has been a common failing component in this generation of trucks that I've seen. So this has determined that the problem for our SCR conversion efficiency code is the SCR itself. So my regen just stopped as I was about to restart recording, and my outlet and inlet NOx sensor readings were almost identical. As you can see right now, they are. And so I'm going to recommend replacing the SCR, and so we're going to have to order those parts and replace the SCR, which is the big canister on the end before exhaust leaves the truck. But don't forget to update this ECM before you let the truck go. So even after you replace the SCR, you still want to do that ECM update because the truck needs it. And I'll show you how to do that on a separate video.